So we're talking about lines today, right? And so let me give you a definition. F of x equal to ax, well, let's say mx plus b is what's called a linear function. Okay? The graph of a linear function is a line. So in particular, what's the equation of a line? You can write it as y equals to mx plus b. All right? We say b is the y-intercept, and m is the slope, right? And remember, or let me just tell you, the slope should be like the rise divided by the run. Sometimes people like to say that. Or you could say it's the change in y divided by the change in x. So that's what the slope is. Now, let's look at a specific example here, try to understand this more. All right. So suppose you want to find the equation of a line, and you're given that the line contains the points, the graph contains the points, this point and that point. All right, and let me be more specific. This point here is 0, 2. And this guy up here is the point, let's say, 3, I guess 5. All right? So given those 2 points, can you draw the line that goes through those 2 points? Right. Well, forget about equations and everything, right? If you've taken a course in geometry in school, you remember 2 points determine a line, right? And all we need to do that, oh, hey, check it out. You got one of these things, right? And we can draw the line, right? That's easy enough. Looks like this. There you go. The question, though, I want to ask is, what are the m and what is b for this line, right? So m is the rise over the run, right? I'm going to say change in y over change in x, okay? And so to see that specifically, let's look at this triangle. So when I say we look at the change in x like this, and the change in y like this, and again, that's the rise over the run. Now, if I go between these 2 points, how much is x changed by? We've gone from x equal to 0 over to x equal to 3, right? So change in x here is 3. How about the y? We've gone from y equals 2 up to what? So it's also 3. Okay. So this m, the slope, we get from 3 over 3. So the slope is 1. Right? Slope of this line is 1. What's the equation of the line? So we slope 1. What's the y-intercept? See, I gave it away. So y-intercept is the place the line crosses the y-axis. So this right here tells me, this tells me that from that I can see that that point right there being given tells me that b is equal to 2. So we've got y-intercept of 2 slope 1, what's the equation of the line? Y is equal to 1 times x, which is x, plus 2. There you go. That's the equation of this line. So our first order of business is how do we find the equation of a line if we're given 2 points, right? Let's work another example. So I'll let you guys pick the points this time. Okay, what point do you want? I just need to give me 2 numbers. There are almost no wrong answers. 1 and 4, okay, sure. So 1, 4. So like a wrong answer would be like e in the square root of 3, right? But you guys aren't sarcastic math majors, so you probably won't do that to me. 1 comma 4, that's that point, roughly speaking. All right, and somebody else give me another point. 5, 1. Okay, let's see here. Okay, so M, and so, I've written triangle Y and triangle X, but how do we actually define those? I'll write them down again here. What that actually is Y2 minus Y1 divided by X2 minus X1, right? That gives me the slope going between the 2 points. So I'm saying that this is the first point, and this is the second point. So you guys tell me, what's Y2 minus, what is Y2, what is Y1? What is Y2 and what is Y1?
Y2 is only 1.
1. Y1 is 4, right? So I got 1 minus 4. How about X2? X2 was 5. X1 was 1. So what do we got this time? The slope is minus 3 over 4, right? Okay. So there's a few different ways to go from here. So in example 1, our life was easier because we were given the point where the line crossed the y-axis, right? That was nice. But this time, we weren't, right? So we can still draw the line, right? You can draw the line. And if we had if we had nice graph paper and, we're careful with our drawing, we could see from the graph paper what the B should be, right? Right? You could do that. But we're going to use an algebraic approach instead. So what we know at this point is that y is equal to minus 3/4 x plus b. But we don't know what b is, right? But what do we know? We do know that these 2 points are on the line, right? So that means that when we plug them into the equation for the line, they have to be true, right? So you can pick whichever point. Let's use Micaiah's point. So Micaiah, sorry. So this gives us 4. We'll plug in the point 1 comma 4. That means y equals to 4 when x is equal to 1, right? So 4 is equal to minus 3/4 times 1 plus b. So that tells me that b is going to be 4 plus 3/4. How many quarters is 4? 4 is 16/4, right? So 16 plus 3 is 9. That's 19/4. Of course, you could also just look at this directly and say, well, that's 4.75, Let's put it all together. What's the equation of the line? Y equals to minus 3/4 x plus 19/4. Or if you want to write it in decimal form, minus 0.75x plus 4.75. Either would be a totally acceptable answer. Now, what do you guys think? Is that algebra hard to do? Not too hard, right? But there is a lazier way to do this problem. There is a lazier way. And so this is, let me get myself a little bit more board space here. Yeah. All right, so definition, the point slope formula for a line through point, let's say x1, y1, with slope m is y is equal to y1 plus m times x minus x1. This is another way we can write the equation of a line. It's called point slope. The equation that I wrote already in class is called slope-intercept form, right? So this one over here, this is slope-intercept. Do you see why it's called slope-intercept? It's not really complicated. It's called slope-intercept. It's called the slope-intercept form because it's written in terms of a slope and an intercept. This one's called point slope because it's written in terms of a point and a slope. So point slope is like super easy for example 2. Like let's do example 2 remix. We use point slope. So we know y, and you can use whichever point you want. I'll use 1, 4, right? So we got 4 minus 3/4 times x minus 1. That's the equation of the line. See, I didn't have to do this algebra. See that? I just got the equation. That is the equation of the line. And then if you want to put it back into point slope, you just multiply. See? This is equal to 4 minus 3/4 x, right? Plus 3/4, which brings us back to, 19, well, minus 3/4 x plus 19/4, or however you want to write it. I mean, so, of course, they're going to have the same equation when you put them in the same format, right? There is also a 2-point formula for a line. You can just straight write the equation of a line down using the 2-point formula. There's that as well. The 2-point formula for a line suppose you want the line through x1, y1, and x2, y2. You can just do this. Y is equal to y1 plus y2 minus y1 over x2 minus x1 times x minus x1. That is the 2-point formula for a line. If you look at the mechanics of what we did in example 2 remix, it's pretty much the same thing, right? It's just like the 2-point formula for the line has the slope calculated here, as we figured out, right? And then you just add the y coordinate of the point you're interested in and x minus the other point. Now, It depends on the question. So like the question might say something like, find the point slope formula for the line, right? But yeah, you can use any of them. As far as I'm concerned, it depends on the nature of the question, right? But stupid wording of questions aside, if it's just if it's a question in the wild, you are allowed to use any of these, absolutely. I personally, as I solve problems involving lines in other courses, I almost always use point slope. I rarely use 2-point just because it's kind of like, it just doesn't tend to come up for me. I usually, for whatever reason, have a slope and a point, and I find myself using that. Let's work a bunch of more examples. If I can find my eraser. Here it is. So did class get canceled during the tornado thing yesterday? I was not here, but I heard about it. Let's see here. Let's see. All right, let's find the equation of the line that contains the points -3, -2, and 2, 4. All right. So I will draw the line because I like to draw the line. Mostly it gives me an excuse to use this ruler. For some reason that gives me joy. There we go. There it is, the line that we're after. So what should I do first here? What do you guys think? You got choices, right? You could. It's usually a good idea to calculate the slope, right? Let's find the slope. So we want to do the y on this one, right? Minus the y on that one. And then 2 minus a -3. Now, that gives us what? That gives us 6 over 5. Now, whenever you do these kind of calculations, you should always stop and ask yourself, does that make sense? Right? Does it make sense? Does that seem reasonable to you? We're going from this point, right? And then like that. Does it make sense that this is 5 over and 6 up? I think it does, right? Because we got to go 3 over to get to the x-axis, then another 2 over to get to 2. 3 plus 2 is 5. And here I've got to go 2 up to get to the y-axis. I should have said y-axis. I got to go 2 up to get to the x-axis. Then I got to go another 4 up to get to here. So 2 plus 4 is 6. It makes sense, right? Slope is 6/5. All right. Now, you guys, this is your class. So you get to pick. Do you want me to do a slope-intercept to find the equation, or do you want me to do point slope? We can go either way. All right, I'll use point slope then. point slope with m equal to 6/5. And let's let x1, y1 equal to, -3 minus 2. We get y is equal to, how's it go? It goes y1 plus m times x minus x1, right? That's point slope. Put in the numbers we have. So that's -2 plus 6/5 times x minus a -3. In other words, y is equal to -2 plus 6/5 x, and what do I got? Plus 18/5. 6 times 3 is 18, right? And let's see here. So to clean things up, this is y equals 2, 6/5 x. -2 is how many fifths? -2 is 10/5, right? -10/5. So I have -10/5 plus 18/5 gives me a net of 8/5. There you go. That's the equation of the line we're after. So whenever I do something like this, I had a few steps here. It's a good idea to check our answer, right? How would we check our answer? So pick whichever point you want. Let's use the 2, 4 point, right? There's 2, 4 actually on the line. So plug in 2, 4. X equals to 2, y equals to 4. Does it work? So we've got, is 4 equal to, question mark, right? 6/5 times 2 plus 8/5. What's that give me? 6 times 2 is 12. 12 plus 2 is 20. What's 20/5? It is 4. Hooray! So that's a good check. Okay. So these problems don't have to be hard, right? Yeah, they don't have to be hard. Now, the equations I've shared with you don't always work. There are lines which are not the graph of a function. What did we learn last time? Remember what we learned last time? Last time, what did we talk about? We talk about functions, right? Have graphs, y equals f of x, right? Which pass vertical line test, right? So there's one kind of line which is definitely not the graph of a function. Well, I mean, here's one that does. Let's start out with one that does. Example 4. If we want an equation of the line which goes through the point, let's say, -1, 2, and 10, 2. What's the slope of this line? What's the slope? This is a horizontal line, right? This is a horizontal line. What's the slope of a horizontal line? So m. So what's the change in y? The change in y here is 0. The change in x would be 11, I guess. Anyway, the point is a horizontal line has slope 0. So what's the equation of a horizontal line look like?
What was the change in x be to 11?
Because 10 minus a minus 1?
I'm sorry, I thought it said 0.
Oh.
It looks like parentheses on my bad.
Oh, okay. Yeah. You were thinking it should be 1, huh?
Yeah.
Or, okay. Well, in any event, so what's the y-intercept, by the way? The y-intercept of this line is clearly 2. So the equation of this line is simply y equals to 2. That is the equation of this line. So when slope is 0, you just get y equals to a constant. It's a horizontal line. And now, does a horizontal line pass the vertical line test? It does, right? If you take vertical lines, right, and you look at how they intersect the graph, they intersect the graph, the green line, in at most 1 point. Horizontal lines pass the vertical line test. And by the way, lines with slope 6/5 also pass the vertical line test. Everything I've done today so far has been in a graph of a function, a linear function, right? However, not every line is a graph of a function. So example 5, if we had, say, we're given the point, 3, 5, and another point, let's say 3, 1, and then you're asked, find the equation of the line that passes through those 2 points. Well, I can draw the line, right? Notice that they've got the same x value, right? What happens when you try to calculate the slope in this case? What would the slope be in here? M would be equal to 5 minus 1 over 3 minus 3, right? What's the problem with that? You got 4 over 0. Are we allowed to divide by 0? I mean, I got a PhD in math. Even I'm not allowed, Like, well, I mean, it's not entirely true. There are places where, well, anyway, I'll shut up. But anyway, undefined, right? Undefined. Undefined slope. Although some people, especially engineers, would say that the slope is infinity in this case. And I think that's a reasonable thing to say. It's an arbitrarily steep slope, right? I mean, if you just nudge that just a little bit to the side one way or the other, then you have a really, really large positive slope if you push it this way. If you push it the other way, you've got a really, really large negative slope. What's the equation of this line? The equation is just x equals to 3. That's it. That's the equation. It's undefined, and so but long story short, horizontal line y equals to a constant. Vertical line x equals to a constant. The vertical lines are not graphs of a function because they fail the vertical line test. They fail it in the most miserable way possible. When you get to this vertical line, it intersects the graph, not in 1, not in 2, but in infinitely many points. This is like the worst possible failing of the vertical line test. So anyway, all right. Let's take a moment to summarize what we've seen so far, right? Let's summarize what's going on here. So I'm going to draw three cases, maybe 4. All right, so we've got lines that look like this, right? We've got lines that look like that. We've got lines that look like this. And then finally, we've got lines that look like this. So let's talk about the slope in each of these cases, right? So you guys tell me. Let's give these. Let's label this case 1, case 2, case 3. And by the way, these labels are not like standard or anything. I'm just making these labels for the sake of discussion. Case 4. So how would you describe the slope in case 1? What can you say? M is what? I'm not asking for a number, I'm asking for a description. So I'll start us out. This would be a positive slope line. If it goes like that, if the rise and the run, as we go from left to right, if we're going up as we go, that's a positive slope. What's this one? Right, negative slope. This one, 0 slope, horizontal line, 0 slope. And this is undefined. Or again, some people will say it's infinity. I was about to worry about what your book said, but then I remembered you guys don't read the book, so, why do I care what the book says? I mean, I sort of care because that's where the homework comes from. And you guys do the homework because you know that not doing the homework is like, I mean, if you're looking for a way to fail the class, the quickest way to fail the class is just not do the homework, right? But you guys are not trying to fail the class, right? Right, yeah. Although for most classes, that is the easier option, right? Like, there are some classes which are literally hard to fail, right? Like you got like some kind of like technology assessment, like prove that you can use Microsoft Word or something. If you do it, it's probably hard to fail it, right? Or like a standardized test, like get a 0 on a standardized test. It's actually probably, it means about as much, right? If you can get a 0 on like an SAT test, that means that you understood which answers were wrong and you chose them. Dang it. So it's impossible. See, what do I know? Thank you. All right. Excuse me. Sneezy. This chalk got to be finally. All right. So we will do more of these next class, but I wanted to sort of go ahead to the next kind of discussion topic for lines, which is parallel versus perpendicular lines. All right, so what do we mean two lines are parallel? And I use the following symbol for parallel. That means what? If they have same slope. All right. On the other hand, two lines are perpendicular. And I get tired of writing that, so I use the following symbol. Right, like that. If they, so let's, to describe perpendicular, I need the formulas. So like the formulas for the two lines, let's say the one is y equals to m1 x plus b1. And the other one is y equals to m2x plus b2, all right? They're perpendicular if m2 is equal to minus 1 over m1. Or if one of the slopes is 0 and the other is undefined. You see why it's kind of tempting to use infinity there, kind of like 1 over infinity, 0. So perpendicular, and you have a, I think I hope you have a, well, let me show you an example of the perpendicular thing and the parallel thing, just to try to make this definition kind of sink in more. So, what example was I on? I've lost my track. I'm on 6. Thank you. Muchas gracias. So we could have y equals to, say, x, and y equals to x plus 1. So these lines both have slope 1, right? So they should be parallel lines. And so we can graph them. The first one has y-intercept what? 0, right? The y-intercept of y equals x is 0. It goes through the origin, and it's slope 1. That's y equals x. Y equals x plus 1 has a y-intercept of 1, right? But it's also got, rats. That was supposed to be exactly the same. So, of course, the parallel lines, if I drew it, if I graphed it right, what do they not do? They never intersect, right? So, yeah. Perpendicular, on the other hand, so I could have, say, y is equal to 2x, right? So that is going through the origin, has slope 2, so it's something like this, right? That's y equals 2x. If I want a line through the origin which is perpendicular to that, the perpendicular line to this through the origin is y equals to minus 1/2 x. So minus 1/2. So this one does what? The rise, it goes over 1 and up 2, right? The perpendicular one goes down 1 and over 2. So it's like this. And that, of course, is a perpendicular line. And the perpendicular lines, they meet at right angles, right? You guys, we don't really talk about angle in this course much, but they do meet at 90 degrees, right? So we don't talk about Bruno. No, I'm sorry. I'm so sorry. Have you guys been subjected to this yet? You don't know about the Bruno? You don't know about not talking about Bruno? How about you? No? You remember Let It Go? Like the song Let It Go? Remember how that was? We don't talk about Bruno. It's the same. It's like that. It will come to you. Give it time. I've already seen it starting to make the rounds. But anyway, there's a new Disney movie with a stupid song. Don't talk about Bruno. But anyway, we don't talk about angles in here until like Math 114. That's the trigonometry. The second half of pre-calculus here is where we actually have a systematic discussion of angles. So, like, don't worry. You just need to know, it's good to have an intuitive idea what perpendicular means, right? Like if you could put a book here and it would fit, you know? Anyway, how do you describe perpendicular without angles? I don't know. Anyway. So there you go. There's our brief introduction to parallel and perpendicular. So maybe that gives you a shot at working homework problems about parallel and perpendicular. And I'll try to work a bunch more problems on Monday. Listen, I'm telling you now, so you know ahead, on Wednesday next week we won't meet, okay? But we should meet again on Friday, I hope. So, modulo, a blizzard,